Here we are doing Stats and Mechanics Year 1, Chapter 9, Question 10. A train is travelling with a constant acceleration along a single track at time t equals 0. Okay, the train passes a point O. There we are. And as it comes along with a velocity of 18 meters a second. So we're doing 18 meters a second at that point. Okay, at time t equals 12, okay, so t equals 12 now, the train passes a point P, very nice, okay, travelling at 24 meters a second, okay, and then at time t equals 20, all right, the train passes Q, okay, find the speed of the train at Q. Okay, so what do we have? We've got a 12-second gap, we've got an 8-second gap. Okay, and we don't know distances. So using this section in here first, okay, let's set up SUVAT for that. Okay, so we don't know the distance, we know the initial speed was 18, we know the final speed was 24, we don't know the acceleration, and we know the time is 12 seconds. Okay, I want to know the acceleration, so I will use v equals u plus at, v equals u plus at. Okay, and so from that we can say 24 is equal to 18 plus 12a. Okay, so 24 take away 18, 6 divided by 12 is a half. So we've got a half meter a second minus 2 as our acceleration. We can then use that for this little bit up here and do SUVAT again. Don't know the distance. The initial speed was 24. We don't know the final velocity. The acceleration is a half and the time is 8 seconds. Okay. And we're doing all of this because we want to know, was it the distance of the time, the speed of the train? Okay, so we're looking for V. So we're looking for the one that has no S in it, okay, which again is V equals U plus AT. So the final velocity is equal to the initial velocity of 24 plus the acceleration times the 8 seconds. Okay, so that's 24, that makes the final velocity 28 meters a second minus 1. All right. Part B, the distance from P to Q. So now we want to do the distance between P and Q. We can use exactly the same one in terms of looking for something with no final velocity in it, which we can now use as S equals ut plus a half at squared. So S is equal to the initial speed of 24 times 8 plus a half times the acceleration of a half times the time squared, 8 squared. All right, so the distance between there and there is, what did I say, 24 times 8. Okay, 24 times 8 is 192 plus, let's do that first, a half times 8 squared, quarter 64 is 16 plus 192 2 gives us a distance of 208 meters. I think that's everything. Distance PQ. Yes. All right.